So in science, we end up dealing with some really, really big numbers and some really, really small numbers. And when you have too many zeros, either at the beginning or at the end of a number, it can be very confusing because it's so easy to get the wrong number of zeros when you write down the number. So we use scientific notation. You should have all learned about scientific notation at some point in your educational process, but you may have forgotten it, so we're going to go over it again. When we write a number in scientific notation, there's two parts. There's the decimal part, here the 1.2, and then it's times the exponential part. So this is the number 10 raised to an exponent. So 10 raised to the minus 10th power. So that's the exponent, this is the exponential part, and over here in the yellow, that's the decimal part. If we have a positive exponent, that means the number 1 multiplied by 10 n times, whatever n is, the exponent. And if it's a negative exponent, then it's 1 divided by 10 n times. So if we have 10 raised to the 0 power, anything raised to the 0 power is 1. But that is 1 times 10, 0 times. So it's just 1. 10 to the first power is 1 times 10, 1 time. So that's 10. We'll skip that one. So 10 to the third power is 1 times 10 times 10 times 10, which is 1,000. Another way to think of this is that the exponent tells you the number of zeros. So if we have, let me get a better color here. Bless you. So 10 to the fourth. Well, that's 1 times 10 4 times. That means it's a 1 with 4 zeros after it. 1, 2, 3, 4. So that's 10,000. Okay. If we have a negative exponent, that's 1 over this number with a positive exponent. So 10 to the first power was 10. 10 to the negative first power is 1 divided by 10, or 0.1. 10 to the minus third is 1 over 10 to the third. So 10 to the minus third is 1 divided by 10 to the third, which is 1 divided by 1,000. If you take 1 divided by 1,000 in your calculator, it's going to show you 0.001. Any questions? So what we're doing in scientific notation is we're factoring out tens. So if we have a number like this, 5,983, that's a big number. We can put that in scientific notation. Well, the way to do that is we take, there's an understood decimal point. There's no written decimal point in that number, but if there was a decimal point, we know it would be after the 3. And we're going to move it over so that it's after the first non-zero digit. So we're going to put the decimal point after the 5. And so we're going to count how many places. So 1, 2, 3. So we rewrite the number with the decimal point after the first non-zero digit. So we got 5.983 times 10 raised to a power. The power is how many places we move the decimal point. Okay? We move the decimal point 3 places. The power is 3. Now, the thing that students get mixed up about is it a positive 3 or a negative 3? Your book has one way of explaining it. This is how I remember. So I look at this number and I ask myself, is that a big number or a small number? 5,000. It's a big number, right? So how do I feel about big paychecks? Do I feel positive or negative about big paychecks? Well, I feel very positive about big paychecks, right? So big number, positive exponent. Here's a small number. This is much less than 1, right? 0.00034. We can put this in scientific notation too. Here's the decimal point. We're going to move it over 1, 2, 3, 4 places. So this is after the 3, 3.4, times 10 to the, and I moved it 4 places. This is a negative 4 because this is a small number, and I have negative feelings about small paychecks. Okay? Small number, negative exponent, large number, positive exponent. So total U.S. national debt in 2013 was approximately that much. Express this number in scientific notation. I mean, that's just a huge number, right? Well, what we need to do is we need to move the decimal point over. So the decimal point, that's actually a period, but the decimal point would be here. We need to move it after the first non-zero digit. So I'm going to write down the decimal part. It's going to be 1, put the decimal point there, and then copy down the other non-zero digits. 6, 3, 4, 2, times 10 to the something. And I need to go and count. Well, this has commas to group. So there's 3, 6, 9, 12, 13. 3, 6, 9, 12, and one more place. It got moved over 13 places. You see that? So the exponent is 13. Then we ask ourselves, should that be positive or negative? Well, is it a big number? It's a hella big number. It's a positive exponent. So this is the U.S. national debt in 2013 in scientific notation. Yes?
You always want to, as far as when you're putting it into scientific notation, you always want to put it after the first number.
Yes.
Or the decimal point.
The decimal point, you move it to after the first non-zero digit. So this decimal part is always going to be greater than or equal to 1 and less than 10. So it could be 9 point something, it could be 2 point something, it could be 1.0, but it's never going to be 0 point something. It's never going to be 27.5. So it's always between 1 and 10.
And you always have to list all the numbers, just not the zeros.
Yeah, we'll talk more about details of that in a couple of minutes, but generally, yes, you're just going to copy down the non-zero digits. These zeros are just placeholders. Any other questions? Questions are good. Usually, if you have a question, there's like a whole bunch of other people that have the same question, but they just don't have the guts to answer it. I mean, ask it. Of course they can't answer it. They have the question. Okay, let's do this one. Express the number 0.000038 in scientific notation. So let's take the digits. We've got 3 and 8. And we want to put the decimal point after the first non-zero one. We're going to just kind of ignore those zeros. We don't want to write all those zeros at the beginning. So we've got 3.8, because as we go from left to right, 3 is the first non-zero digit. And we've got times 10 raised to some power. And then we have to figure out how many places did the decimal point get moved. 1, 2, 3, 4, 5. So the exponent is 5. Should that exponent be positive or negative? Negative, because that was a small number. Okay. Your book, I think, talks about moving it to the left or to the right for large or small, or I find that confusing. Any questions? I'm going to do another example there. Let's make one up. What about going the other way? What if we had, got to choose a marker to do this, 5.49 times 10 to the 7. How do we take a number from scientific notation and write it in decimal notation? Well, this is telling us how many places to move the decimal point, and the sign tells us whether we're going to make this number bigger or smaller. Because this is a positive exponent, the actual number is very big, and so I'm going to move the decimal point to the right. So here's 5, 4, 9. The decimal point was here. I need to move it 7 places. 1, 2, 3, 4, 5, 6, 7. Well, I can't just leave spaces like that, so we need to fill this in with zeros. and then double check. So here's where it was, 1, 2, 3, 4, 5, 6, 7. So this is the decimal notation form of this number in scientific notation. Okay.